Hello there. So let's keep working with this case. So I was checking the Fluent dataset. So previous video we worked in OpenFOAM dataset for computing moments and forces. So in this one I was checking Fluent dataset. So yeah, let's revisit. So here I already have the pipeline. I'm not going to do everything. So just to show you. So in video description you should have the link to download everything, and I'm going to reproduce the steps and to explain some things there to clarify something. Bam, 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 load state here. So this one is state in 1 moment, and here remember to point to the file here. This one, you go, and you will open the data. So pretty much you're saying, okay, we have seen that we have the file with all the forces. So I have some notes there. So all the forces and so on. So here let's go and revisit our pipeline. We read file. Remember, I'm saving everything self-centered. For some reason, for moments it might be better to do points, and we're going to see that. So here I extract the pipe, small and large. Okay, extract the surface. Okay, apply normals. Cell size, I compute the area, everything, okay, cell center to this moment. And then here I have wall shear stresses for some reason. And let me go here. Fluent doesn't save the vector, so this is how to convert a vector. So recall the previous video we saw how to do it with the I hat, J hat. So I converted wall shear stresses to a vector to use it. So at this point I convert everything that I did previously from cell data to point data. Okay, and here I start to create my calculators, okay, and point data. So the first one is to compute total. Okay, so this is summation. Remember that now Fluent will be absolute pressure minus this one to get the relative normals and wall shear stresses, the vector I just assembled. Okay, so here I'm just getting the total of these two fields, okay, that they have units in Pascal, they are not the force. Okay, then calculator 3, I compute the moment, so it's the cross of total, the reference vector 0, 0, 0, I hat, J hat, K hat. So we saw with wall shear stresses that you are basically assembling a vector, and you get the coordinates here. So, and that's it. Okay, so at this point, okay, in this one we apply integrals. Okay, so in this one we integrate to get moments and forces. Okay, so then here I go back from point data to cell data now. So just to show you the difference, but in particular moments. So if we look here, this is the integral of this calculator to what we have the total. So look at that, our total forces, okay, when you integrate corresponds now to the forces that the reference one. So there is no issue there. Then in this one we have the moments, same issue. So here recall that in calculator 3 we compute the moments. So this is the total of the field. When you integrate, you are going to get the actual quantity here, and these are your moments. Okay, so you compare with moment files and you have it here, so no issue there. So at this point it's quite easy. Okay, as you see, we're working with point data. So the issue that I'm having, probably missing something, correct me and just let me know. But in any case, this point will be much easier to work with point data. Now I go here, everything that I have here, I convert it from point data to cell data. Okay, so my calculator, total force, okay, remember total times area, my Python calculator, and I get my force here. Okay, so there is no issue. So this is the remember here we do the summation. So here you have your expression, summation is this one. So some error there, maybe in those conversion, but it is okay. So you can change, different. So we can go here and do component 1, 0.16. So some differences there, but it's not a big of a deal. Or probably can be a reason why I'm getting a little bit far in moments when using cell data. So just to stress, up to this point, here everything was okay. By the way, here also is quite cool now because you can compute the center of pressure of the body. So remember, the center of pressure is the point about which the moments are zero. So just basically, well, here will be much easier to use programmable filter, and then you change now the coordinate of this point until you find that one, or you can go here, iterate, and put different points until you find out your moment should be zero, okay, or at least the set moment it is zero. So if you're interested in that one. In any case, here we went here point data, cell data. So we see the forces are okay. So now we want to compute moments, okay? So in moments is a little bit tricky. I may be missing something, doing something wrong. Okay, so first things, cell centers. I get my cell center. So why do I get these cell centers? And let me go back to the moment calculator, because you only get access to coordinates. When you are in point data, you get the coordinates only in point data. But as you go to cell data, you don't get those data. And actually, let me go to the beginning here, for instance, in any of these calculators. See that you don't have coordinates here. So what I do here is when I cell data, get the cell center. This is a filter that you have somewhere here, center, cell center, and you get the cell center data. Then I save the centers in the coordinates now in centers here, and then here I pass that data. Okay, this one that you have, I call it array center, get coordinates. Okay, I pass that data here. So probably my mistake is here. I don't get it right. But in any case, then you compute the moments, and the moments you have total force, cell center. Okay, where in cell centers you get the same vector, and here you get cell center data. And to show that in here, I already have my cell center data. Let me use this one. Okay, so you have the centers and you have your coordinates, X, Y, and Z. Okay, so when you apply that filter, say that it's getting your centers and plotting that. So yeah, so when I go here, you compute everything, you go and compute your summation of moments. Here's where I get a difference. So for forces, it is okay. So probably in those conversions I did, I had some error, but in any case, I'm satisfied with that. But the summation of moment, see that this is the set component that I have to set, the last one, and see that it's very far away from what it should be. So I guess it's this conversion. Remember, if you use point data, it is okay, there is no problem. But yeah, I need to check this with cell-centered data, how to get the right moments. Probably, I think I'm making a mistake here getting these cell centers. I don't know, might be the case, might not be, or the coordinates that I'm using. But let me check that for all purposes. Now remember that you can do everything point data. Okay, so if you use point data, is pretty much out of the box now. So here you have it, we convert everything, and then you apply your calculators to total of the fields and then total of the moments, and you can integrate those two. And same concept, you can take this field, multiply it by area, and you get the force, and you can plot your force on your surface, and will be the same with the moment. You know, get here the total force, and you can plot that there. So yeah, just to revisit this one, as you can see, it's the same stuff as OpenFOAM Fluent or any solver. I mentioned that I like to use Insight data as the fastest one, but for our purposes now, any data will work. Yeah, be careful now also as you export in cell-centered or point-centered, also the vectors. So you see here that, for instance, we needed to assemble the wall shear vector just to make your life easier, but it's not like it would change much. So yeah, this is it. So now we cover this case, different datasets, different solvers, different methods to do things. And one cool thing now that I mentioned now, that to compute this the center of pressure, now you can come here and find a point where moments is zero. So that's all. Hope you like it, okay? And see you next time when we will address unsteady data that pretty much is the same stuff. So bye.